So looking at this process of mass transfer, what we have in all cases is we're looking at having, in this case, it's shown here with a chemical in the bulk gas phase. This could be oxygen. We need to transfer that chemical to the air-water interface. Typically, we would have a stagnant gas film on the gas side. It has to cross this interface. We have a stagnant water film that's actually thicker, quite a bit thicker than the gas film. And then it has to move out into the bulk liquid. So we have diffusion of the chemical to the surface. We have transfer across the air-water interface. And then we have diffusion away from the liquid. Or it can be the opposite, in which case it's diffusion from within the gas phase, within the liquid phase, and then mass transfer across, and then diffusion from the gas phase. If we can mix this, we can increase the rate at which that chemical then approaches the interface. Now, the design, all of our design is based on Fick's law, which describes this mass transfer across the air-water interface, and Henry's law, which describes the relationship between the concentrations in the air and the water phases at equilibrium. So the rate is a function of the mass transfer efficiency times the difference between the concentration in the air and the concentration at saturation. Okay. Or we can write it in terms of the water. And this tells us whether diffusion is from the gas or the water interface. So, for instance, if we're looking here and we're looking at oxygen, so let's look at the situation. If we have, let's say, C star is equal to 10 milligrams per liter, and C water is equal to 7 milligrams per liter, which direction is mass transfer? From the gas to the water or the water to the gas? It's from the gas to the water. Okay. Now, let's think about this. Same thing. So the equilibrium concentration is 10, or saturation concentration is 10 milligrams per liter. And the concentration is, it's oxygen. Think about this. Have you ever turned on the faucet and you fill up a glass of water and the water is cloudy, but you let the glass of water sit and it becomes clear? Anybody ever observed that? At least one. What's happening? Two, why is that water cloudy when it comes out of the faucet?
Is it oversaturated?
Exactly. It's oversaturated with oxygen. So what's happening? Why is it becoming clear?
Some of that oxygen is leaving the water.
Exactly. The oxygen's being transferred from the water to the air, and it becomes clear. So what you're actually seeing are very fine oxygen bubbles, and that's why it's clear. There's nothing dangerous about it. It's just oversaturated with oxygen. So in this case, the transfer is going to be where I've shown here. This is your cloudy glass of water. The transfer is from the water to the air. So that difference tells you whether transfers from the air to the water or from the water to the air.